Thank you. So welcome to everybody. I'm Diana Bowman, Community Development Officer, and I'm joined by my colleagues Jackie Newey from the Health and Wellbeing team and David Darby, our tech support. We're delighted to be running this first workshop to kick off PAVO AGM week, the Green Recovery, focusing on buildings. Thank you all for attending. We're recording this session. We'll also mute everyone's microphones during the presentation to cut down on background noise. I'd now like to introduce Gareth, who I've known for many years. Gareth Ellis is from the Green Valleys KIC. Based in Brecon, the Green Valleys is a multi-award-winning community interest company that supports community-led action on climate change. Gareth currently works on the ECHO project. This is an Interreg Northwest Europe project, which is funded by the EU and Welsh Government to support development of more community energy cooperatives. This morning's session will look at some simple measures to make community buildings more energy efficient. Many buildings are now closed, of course, at the moment. So now is a good time to look at your energy bills and see what you're paying for gas and electricity, and maybe consider some small low-cost maintenance tasks and improvements that will help you to reduce your overheads as well as your carbon footprint. Okay, over to you, Gareth.
Wonderful, thank you, Diana. Let's see if I can get my presentation up first time then. And thanks for the introduction, Diana. As you said, I'm talking very basically about a few things that you can do in community buildings. Obviously, a lot of the community buildings around Paris are incredibly important for a lot of community activities. Lots of difficulties this year with the centres being closed. And one thing we can obviously do to try and keep these buildings in use and keep them cost effective going forward is to do as much as possible to reduce their running costs of bills. Obviously, I can't see any particular building from where I am today other than my own house, so it's quite generic. But we will be taking any questions in the chat. If you found where the little chat function is, please do put any questions in there as we go along, and I will address them in the natural sort of breaks in between various subjects. So, without any further ado, I will get my presentation running. So what we'll cover today, I'm specifically looking at advice for community buildings. It could be village halls, church halls, sports clubs, rugby clubs, whatever building your community may have. A lot of these will be applicable to a lot of buildings. But if you do have anything specific, then you will potentially need to ask that in the chat. So first off, we're going to talk about managing your bills. Bills aren't particularly exciting. Often in my experience, the bill arrives at a community centre, it goes to a treasurer and it gets paid, and it often doesn't actually get sort of looked at. So we'll have a little bit of a session first off about how to understand and read your bills, and that's going to be very important to decide whether you're getting a good deal from your energy suppliers. Then we'll go on and look at heat. Heating your building is usually the single biggest cost when it comes to energy. So we'll look at how you heat your building and ways of keeping that heat inside. And finally, we'll look at lighting and appliances, the sort of electrical use in a typical building. So benefits hopefully will be fairly self-explanatory. Obviously, if you can reduce your running costs, you reduce the overheads for the building, reduce the higher costs, hopefully give the building committee a little bit more money to spend on some more fun things than paying your bills. Obviously, if you can reduce your energy use, it reduces your carbon footprint as well, which is becoming more important for many groups. It's a good time now, potentially, if we are looking at periods where the buildings may be closed, particularly closed over winter. There may be some tips here that can help reduce your costs over winter when the building's empty. but I'm really only looking at those things which are low cost and straightforward, the sort of things that most groups should be able to do. So I'm not going to talk about things that involve 30, 50,000 pounds of investment, though obviously older community buildings, you could spend a significant amount of money improving the energy efficiency. What I'm looking at today is really the sort of things that you can do fairly quickly with a bit of effort and for fairly low cost. So perhaps 50, £100 sort of cost value. So first off, managing your bills. I'm really going to look at gas and electric. Some community halls around Paris may, of course, use wood or oil or LPG, which, because you have those fuels delivered, we sort of manage the billing of those in a little bit of a different way. So I'm really just going to look at the gas and electric. And your bills are made of three parts. The energy you actually use, which is measured in kilowatt hours. And we'll look at how kilowatt hours are measured for electricity and gas. A standing charge, this is a cost usually per day or per month. It's effectively a cost for sort of managing the meter and managing the supply. And your third part is the VAT that will be added. It's important to note that we're used to 5% VAT for domestic, which is what we have on our household bills. You should be able to get that as well if you're a charity. And shouldn't necessarily be paying the 20% commercial rate if you're a charitable organisation. There is advice from HMRC on that, or advice from accountants about how to make sure that if you are a charity, that you get that 5% rate, not a 20% rate. Here's an example of a bill. It has come. Bill is incredibly important to taking charge of your energy use and understanding how your energy is used. So this electricity bill, see, I've got my pointer. Oops. If you bear with me a second, there we are. Yeah. So yes, my pointer. You can see that the bill here for electricity was estimated previously, and it's a customer reading now. That's always worth checking on your bills, whether you're getting an estimated bill or they've had a meter reading. It's good practice to keep your bills up to date. I have seen bills at a community centre where they had been estimated for over 3 years because no one had ever been there to be able to read the meter. So what they'd actually paid was quite a lot less than electricity they'd actually used. So they were going to get surprised with a large bill. So if you can keep it up to date with a customer meter reading, that is important. On this bill, they've used 443 kilowatt hours of electricity. It's easy to read off the bill because your electricity bill reads in kilowatt hours. So the actual numbers on the meter show you how many kilowatt hours you've used. Here is the day rate, the unit rate, 14.92 pence per unit, and the standing charge, so 53 days at 9.4p per day. Pulling these bits of useful information out of your bill are essential to then be able to understand if a different supplier is going to give you a better deal or not. And the bills, they have got better, but they can be a little bit confusing. So you're really looking for these prices per unit for the kilowatt hours and for the standing charge. So that's important to pick those out. And here, of course, this is domestic bill. The VAT is at 5%. The gas bill is ever so slightly different because your gas meter doesn't read kilowatt hours. It reads a volume of the gas. So here there is a calculation that shows how that volume of gas is converted into kilowatt hours. Our unit, in this case, I think it's 120 units have become 1,404 units of kilowatt hours. A price per unit again, and the standing charge, just as we had before. There's a dual fuel discount on this one, which is applied to the gas. And of course, you've got the VAT at the bottom. So that totals up your bill. That may be straightforward to some of you, but I know that the bills can cause a lot of confusion, and bills is often something people don't really want to dwell upon. You get them paid and you try and forget them. I can't sort of stress enough that taking charge of your bills and understanding your bills is one of the first things that you can do to really get a handle on how much energy you're using and where you may be able to save. So this really leads us to switching tariffs. Most people never switch. The energy companies know this. If you keep paying a bill, they will keep charging you that rate. It's that simple. All of the energy companies will do the same. There's very little onus on them to find you a better deal. Though some will, if you keep paying it, they'll keep charging you that bill. If you can check what your annual consumption is, there's a graph here which is taken from one of the bills, and this gives you an idea of how much gas and electricity you use throughout the year in kilowatt hours. That's very useful if you can find that off your bill, because you'll need that along with your standing charge rate to have an idea of whether a new supplier will be able to save you money. So that's finding out what your unit rate is for the kilowatt hours and what your standing charge rate is for the meters. If you can pull those off the bills, you're in a really good position to decide whether a different supplier might be for you. You can obviously use comparison websites, of which there are plenty advertised almost everywhere you look. But I do know that the Development Trust Association for Wales offer an energy action group. This is effectively an energy broker service that they offer to community groups. If you speak to them, you can consider appointing them as your agent, and they will go out and find you a deal, a better energy deal, and then they will be able to offer that deal to you, and you'll be able to decide if that deal is for you or not. I think that there are potentially other broker services around, but I certainly know that's quite successful. And as an example, I provided some advice to a church in Merthyr, and they saved around £350 a year just from changing their energy suppliers, because they hadn't changed their supplier in years, and were still paying quite an uncompetitive rate. So it is worth doing. Does anybody have any questions for me so far?
But if there aren't any questions...
Actually, I've got a quick question. With my other hat on, I'm a volunteer for a community building in Paris. You mentioned the broker services. Is there any charge with their use, or is that funded so that it's free?
I don't believe so. I think they may be able to charge the energy supplier if somebody signs up, like an agency fee, really.
Right.
Though I don't believe there's any fee to you to use that service from them.
Okay, that's good then, isn't it? It's definitely worth sharing that information with the sector, I think.
It is, and I will include some links at the end of the presentation, and the presentation will be available for download. So there will be a few web links on there to some useful resources that I'll mention during the talk.
Great, thanks, Gareth.
Okay, with it all sitting comfortably, I will continue. So
There's one more hand up. Martin Nosworthy would like to ask a question. Do you want to unmute yourself, Martin? Do you want to unmute yourself?
Okay, yeah. I was just wondering if you got any thoughts about smart meters, Gareth.
Smart meters are coming. If you can get smart meter fitted, it obviously avoids the need for you to take meter readings. It does mean that your billing should always be up to date, so you won't get a surprise big bill if estimated bills have been lower than you expected. Yes, smart meters coming. We need to use the cables. The national grid needs to be used in a smarter way. And smart meters are the only things that can help us do that. So they are coming. I think there's been a lot of negative press about them. I think some of that is overblown. A lot of people are distrustful. They think that the smart meters are there to benefit the energy suppliers. The only thing I can say there is if they really were to the benefit of the energy suppliers, we'd all have them, and the rollout would have been done very well. So it's they help us as consumers. So
does it complicate switching suppliers?
It shouldn't.
Okay.
Whether that does or not, there have been obviously a lot of horror stories with people saying, well, if you change your meter, you can't change your energy supplier. I suppose the important thing to remember is, of course, your meter isn't really your meter. Your meter is sort of owned and the responsibility of your energy supply company. So it doesn't bother me if the energy supply company wants to come and change the meter every time I change supplier. It's their responsibility. It doesn't cost me anything other than being in and having the electricity off for half an hour while they do it. So if they want to keep spending money on changing meters, it personally doesn't bother me. But yes, I think that there's a lot of negative things written about them, but the simple fact is that they are going to come in, and we are all going to have one at some point. So,
okay, thank you.
But no, good question. I thought it might come up. So, heating a building is usually the single biggest sort of cost on energy. And a good way to think of it is like water in a bucket. You want to use your boiler, or in this case a tap, to fill your building or a bucket with lots of hot water or hot air, in this case the water in the bucket. It's easy to see that if the bucket's got lots of holes in it, you have to run the tap for a lot longer, or run the tap a lot harder to keep your bucket full of water. This is exactly the same with your boiler straining to keep your building full of hot air. If you can think of it this way, you'll be able to realize that any of those gaps, anywhere where that heat escapes, is what forces you to run the boiler for longer periods. So filling your rooms with air, you want to be able to keep all of that air in as much as possible. And what you'll often find is that you have a lot of holes in your building, regardless of whether you think of them this way or not. Couple of pictures of doors here. Obviously, one old door, very poorly fitted. Lots of small gaps around it. Huge amounts of drafts that come through. Very difficult room to heat because it's got all these gaps. Or perhaps a little sort of less obvious is the large gap underneath this door here. They often get sort of dismissed, these small gaps, but I can guarantee you, if any of you are sitting in the room where you are now, if you went and opened the window just a millimetre or two, you'd very quickly notice the drop in temperature. And of course, this is what these gaps and drafts are doing. It's like having the door or window open. If you've got the door or window open, you can't heat that space. You start really struggling to get the rooms up to temperature, and you run boilers for very long periods of time, which costs a lot of money. But the good thing about these sort of small gaps and drafts is they're usually quite easy to fix and fill. So things like draft excluders, 10 or 15 pounds, quick job with a handyman. You can get some of this self-sealing tape around doors, particularly around windows. Windows that are either older windows or windows that get open and closed a lot, like kitchen windows, bathroom windows. The seals can begin to fail. They're made of plastic and rubber. They don't last forever, but they are quite quick and easy and cheap to replace. This sort of window seal stuff is, £5, £6, £7 maybe for a roll. It's self-adhesive. You can use it to plug gaps. Even things like the keyhole covers. That's just a small gap that's constantly letting hot air out and letting cold air in, let alone something like a letterbox, which of course is a huge hole in your door. These sort of brushed covers, things like that, can really make a big difference. I know this from experience. I live in an old house, and I spent a lot of time with filler going around plugging tiny gaps. And when I'd done them all, the difference in my sort of temperature in the lounge was noticeable. It was 3 or 4 degrees different just by stopping all these small, seemingly insignificant drafts. They all add up. So that's something that should be fairly easy to spot. You should be able to see where light gets in, or where you can feel drafts around window seals, things like that. And even though they seem small, if you can plug quite a few of them in a building, they will make a difference. Another important thing with heating is really just heating spaces when you need to heat them. There was a good example that when I visited this community centre on the left here, they had some builders in. So the builders had all the doors open because they were going to and from. And all the rooms that had the doors open had the heating system running, and the heating system running at full whack because the thermostat was telling them that the room was cold. And they'd been doing this for, you know, literally weeks while they'd had this building work on, running their central heating system while all the doors were open with the building work going on. So have a think about what spaces in the building are actually being heated and which ones need to be heated, and try and avoid heating rooms with doors and windows open or heating empty spaces. That's another one that you see often, particularly with a sort of wet radiator heating systems where all of the radiators go on together. You end up heating all of the rooms in a building, even though if only one or two of those rooms are actually being used. You may also find that a lot of people will open windows to get more fresh air in, particularly where community centres and others are being hired to third parties. People generally don't want to touch the boiler or don't have access to the boiler. So if the room's too hot, they'll open the window. So if you've got the heating system running and the window open, you may as well just be throwing £10 notes out of the window, because that's what you are literally doing. If you've got a heating system running with windows open, your heat is just going straight out. So watch out for that as well. There's a tip I'll give you later on managing the heating system to deal with that. And finally, the image here at the bottom, all these doors and window, corridors and fire doors left open in a community centre. Very, very difficult to heat this kind of space where you've got drafts and air movements all the way around. Close those doors, cut down the amount of space or the amount of air you're trying to heat. Stop those drafts circulating and keep the rooms cozy where you want them warm. It's also a good idea to not really bother too much about heating things like corridors. People don't tend to hang about in corridors, so they don't get cold. People walk through corridors, so it doesn't matter if it's a little bit chillier. It's much better to have the chilly corridors and warm rooms, because when people are sitting, when people are watching or chatting away or working, that's when they get cold, when they're sitting still, not when they're moving about. So things like, yes, corridors, stairways often don't really need to be heated to the same level as rooms. I'll only mention a little bit about insulation. It is a specialist area. If insulation is done incorrectly or done poorly, you can develop problems with damp by sealing the building and not letting the building breathe. Obviously, things like having the roof voids insulated is quite quick and simple these days, like the top picture. Things like walls and floor insulation is often a lot more expensive. Unless the work needs to be done to deal with sort of a damp problem or potentially sort of problems with rendering, stuff like that, it's often just too expensive to do purely as an insulation measure. But if you have to do those jobs for some other reason, that's the time to look at getting your insulation done as well. Unfortunately, a lot of these external wall cladding or what have you, it is just very, very expensive. For a typical sort of community building, tend to be large buildings, not necessarily occupied all the time. It's difficult to then earn your money back on the bill savings, but it's worth looking at if you need to do other renovation work. And
Gareth, I've just had a message in the chat. Somebody said they couldn't hear what you said about the roof void insulation. Could you please repeat that a little bit, please?
The roof void insulation. If you've got a roof void like this image at the top right, fitting this blanket type insulation should be fairly straightforward and quick and easy. I'd still contact a insulation specialist to get advice and to make sure it's done properly. But it shouldn't necessarily be too difficult or complex to do. whereas wall and floor insulation is often a lot more complex and a lot more expensive. Hopefully that covered the query?
Oh, I've just got another comment. I think, Nicola, can you just indicate on the chat if you're happy with that?
Yeah, Nicola said
Yes,
thanks.
I just
chat,
said.
so-
Okay, thank you very much.
No problem. And the final thing, of course, double glazing. Double glazing is a good way of insulating your building as well. Again, it tends to be quite expensive compared to the savings that you will get, but double glazing has other benefits, particularly cutting down things like road noise if you're next to a main road, and of course it can increase the the security of your building by having good, well-fitted, locking windows as well. So double glazing is always something that's worth looking into if you can. So as well as keeping the heat in, we've got to get the heat in the first place. So a little bit about some heating systems. I'm going to really look at gas and electric. Gas tend to have a single boiler. There's one up here on the top right, and it distributes hot water to a series of radiators. Electric heaters are often, you have a separate electric heater in each room, like this convection heater down here on the picture on the lower right. We'll look at both. There's pros and cons to both. I guess the best thing from the gas one is that you have one boiler to heat all of your rooms. Unfortunately, that does mean that it can be difficult to control which rooms you're heating. When you have electric ones, which have got electric heaters for each room, it's quite easy to just heat one room at a time, but it can be a bit fiddly that you have to go around to all of the boilers, whereas a gas boiler will have just one set of controls for the whole building. Oh, I'm jumping around a bit there. It is essential to understand a couple of things about your heating system, how your boiler works. That's very important. And how the timer controls or any of its sort of functions, how those work. I have visited a lot of community buildings, and people are often quite scared of their boilers. They are designed for the layman, for people like me to be able to use. You don't need to be a plumber to actually operate them. And if you don't take charge of your boiler, you'll never be in charge of your heating system. They aren't that complex. They aren't something to be scared of. And learning how your boiler works and how its functions works is absolutely essential. And you also need to be able to identify potentially when there's problems, so that you know when to get somebody in to come and help you with a heating system which isn't functioning properly. Image here of a gas boiler. A couple of controls which are very useful to understand are the two dials down here at the bottom. Very simple controls. You have a low setting and a high setting. And you also have a symbol here. This is a radiator and this is a tap. Believe it or not, they're not necessarily great symbols, but that's the temperature of your hot water system, your radiator system, and this is the temperature for your taps. A couple of things to note on these are the setting for the radiators is useful to consider changing that throughout the year. This is a sort of time of year where it's been fairly mild so far, so you might have that setting still a bit lower. As we move more into the winter, you might move that setting up a little bit. The higher it is, the warmer your rooms should come to temperature by having a higher output. So if you have a sort of community centre where you might have occupation for an hour or 2 hours, you might want to have the boiler set quite high, heat those rooms up to that temperature, and then you can turn the boiler off. If it's something more like maybe an office space where the room is occupied all day, you may have the temperature a bit lower and run the boiler for a longer period, so that you have that nice sort of even temperature throughout the day. The hot water coming to the taps, one thing I would note on this, in this example, it had been turned all the way up. That water is dangerously hot. coming out of the taps there, particularly if you've got people, you know, senior citizens or others who may have a vulnerability. That water is scalding hot because it's been set too high. That only really needs to be set at a level where it's, you know, perhaps just a little too hot for your hands. I have it set at home where if I fill the tub to do some washing up, it's just about too hot that I have to put a little bit of water in. If you have that overheated and you find you have to put a lot of cold water in, you're wasting your energy. You're overheating that water and then just putting cold water in to cool it down. So that's one thing. These are dials. You can turn that down. It's a very simple control to use, but it's important to understand that you have two: one for the heating system, one for the hot water system, and can control them as you see fit. Also, up in the top right of the image here, you'll see there is a pressurization, if I can say it, gauge, which I'll just open. As you can see in this example, all the pressure has gone. I don't quite know why this is, but boilers need to be pressurized fairly regularly. It's something that users can do themselves. You don't need to have any great technical expertise to do it. I know I have a boiler at home I need to pressurize probably about twice a year. Unfortunately, the boiler at my mother's house loses its pressure in a month, so it needs to be constantly repressurized. If you're confident, this is a fairly simple job for users to do themselves, or at least keep an eye on where the pressure is on your boiler, because if the pressure's low in particular or high, your boiler won't be running efficiently. It's the sort of thing, if you get your boiler serviced, get your boiler service person to show you how to repressurize your boiler system, because it isn't complex, and if it's something you can do yourself, it helps keep your boiler running efficiently if it's correctly pressurized. Controls. Most systems will have some sort of thermostat control, or maybe a timer system like the one on the image on the left there, much more complex than the simple thermostat. The important thing to remember is your thermostat will measure the temperature where it is. And often you'll find thermostats are located in things like lobbies and entryways near front doors. So you might find if a front door is opening and closing all morning, it lets loads of cold air in. So the lobby is cold, so the thermostat is cold. So it keeps running the heating system because it thinks all of the room is cold. The thermostat only measures the temperature where it is. So it's worth remembering that here in this example, if the thermostat is set at about 20 degrees, your hall where the thermostat is might never reach that, but your room might reach that temperature quite happily. So it's just to remember your thermostat can only measure the temperature where it is, and have a think about that in your community building. If it's somewhere particularly cold, then you may want to adjust your thermostat down a bit to control the room temperature elsewhere in the building. Not sure I've explained that particularly well, but basically your thermostat is only measuring the temperature where it is, not necessarily the room that you want to heat. If you can upgrade from a sort of simple thermostat control to a programmable system, programmable systems are really good in community buildings. If you know when your building is going to be occupied, you can get a 7-day programmable timer that will set the heating on and off at different times for different days. That's really good if you know that your community centre gets used on a Tuesday morning, then a Wednesday afternoon, then a Thursday evening, then all day Friday, then nothing on Saturday, or maybe just Sunday afternoon. You can set that heating system to come on just when you know the building is going to be occupied, and you can avoid those periods of heating a building that's empty, because if your timer does the same thing every day, it will keep heating your building perhaps during the weekend or times when you're closed. So anytime you can cut down the length of time that you're heating the building, you're going to save money. Little word on radiators. Radiators are not radiant heaters, they're convection heaters. And convection is basically the airflow where cold air is heated by a radiator and it circulates around your room. So convection heaters, radiators, they're trying to cycle all of the air through the radiator and heat all of the air in the room. That's a good reason for keeping things like the doors and windows closed, because remember, you want to cycle that air through the radiator as quickly as possible. And it's also a very good reason for not blocking the radiator. So you often see people pile coats on the top, or sometimes they're blocked with sometimes furniture stacked up, things like that. If you can keep the radiators with a free airflow, then this convection current can be set up in the room, and you'll start to heat your room sort of quite efficiently and effectively. If you find that the room takes a long time to build up to temperature, it might well be because the air isn't forming this convection system through the radiators perhaps as well as it should. So you might have to have a look and see if are the radiators blocked by anything. And it's very easy for things to sort of pile up and accumulate around radiators. What you can also do with radiators, most modern systems will have one of these, a thermostatic radiator valve. These are really good for controlling which rooms you heat and which rooms you don't. So if you find that the room has reached temperature, you can turn the radiator down and keep so you don't need to access the boiler system. You can just turn radiators down, and you can turn radiators off. So if you might find that with your radiator system, if one room is empty, you can turn the radiators off in that room and avoid heating that empty room. You may also find that if there's rooms that are particularly drafty, you might have the boiler temp, the radiator valve set high in that room. And if there's another room, say a small room that might overheat, you can set that at a lower level. So these allow you to fine tune your overall boiler temperature to each individual room by turning them down or turning them off. It's good if people understand how to use those, because if you find the room is too warm, as I said before, what a lot of people will do is open the window, not turn down the radiator. And obviously turning down the radiator is a much better solution to an overheating room than it is to open the window and leave the boiler running. Radiator systems can accumulate air. Hopefully most of you will be aware of a bleed valve at the top of a radiator. In community buildings, these are the sort of things that get forgotten. Unless there's a sort of checklist once a year, your radiators may not have been bled in a long time. It's quick and simple to do. You can find instructions on a quick internet search if you're not sure what to do. And if you're not sure if your boiler needs bleeding, it's quite simple. When the system's running, see if it's cold at the top. If the radiator is cold at the top, then air was accumulated in the top of the radiator and the water isn't circulating. So that air needs to be bled out. But just as a word of warning, check your boiler pressure after bleeding the air out of your system, because bleeding the air out will reduce the pressure in the boiler system. So you may then need to repressurize your boiler if you bleed a lot of air out of your radiators. Also, your radiators can get cold at the bottom. The radiators are a closed system, so the water circulating in it today is the same water that was put in when your heating system was last sort of serviced. So that means that water could have been in there 20, 30 years circulating around. It will eventually corrode the inside of the radiators, and it forms these sort of nasty accumulations of sort of rusty sludge. If you find that your radiator is cool at the bottom, then it's probably clogged with some kind of debris material in it. Cold at the top, bleed it of air. Cold at the bottom, your radiator system really needs to be drained and flushed to remove all this material. And it can also, obviously, the rust can eventually sort of damage the quality of your radiators. So you can see the distance between a sort of dirty radiator there and a clean radiator. So if you're finding radiators are wet at the bottom, cold at the bottom, it's worth considering having them flushed and refilled. Obviously, it's improving the efficiency of getting that hot water around your building. Excuse me while my phone goes. Word on storage heaters. Storage heaters are only really of use if you have a daytime and a nighttime rate for your electricity. So if you're not on an economy 7 tariff, if you're not getting cheap electric overnight, storage heaters are not really of much use at all, because they're not a particularly efficient heating system, but they make use of the cheaper energy rates that you can get overnight on economy 7. The cutaway here shows you that the very simple elements with thermal mass, basically bricks and tiles. You heat them up overnight and then you let that heat out during the day. I find they're often not very good for community buildings, because community buildings are not necessarily used in the same sort of periods each day. And they also require you to take a bit of control of them, because they have these two controls, an input and output. Basically, each evening, if you're going to close your building, you need to turn the input up and the output down. So that will charge up, that will heat up the storage heaters overnight. And then in the morning, you turn the input down and put the output up, and you let that heat out during the day. They're particularly ineffective, I think, if you've got community buildings which are used during the evening, because even if you've charged them up overnight, they've let all of their heat out by the day. They just can't store the heat for that long. So storage heaters are very difficult to work effectively with a sort of typical community building. Modern ones have better control systems, but they often just don't seem to function particularly well. So it may be that you would consider an alternative to a storage heater system. They're just not ideal for community buildings. Some other heating systems that you tend to see used are fan heaters. They're convection heaters. They want to draw all the air through themselves, heat up the air on an element. So if they're very similar to a radiator, they're just sort of fan assisted. They're very good for heating the air in small spaces. So something like an office where you can close the door. Even a small fan heater will quickly cycle all of the air through the element, and it will heat up the air in the room. If you have a large room like a village hall or a sports hall, they're next to useless. There's so much air in that room that you're trying to sort of cycle through a small fan system that unless you're sitting right in front of it, you'll often find that a fan heater will struggle to bring a large room to temperature. So fans they're good in small rooms where you can keep the doors closed and have a small volume of air. Larger spaces, they're not so good. Halogen heaters, radiant heaters, these work in the opposite way really to fan heaters. The radiant heaters don't heat the air in the room. They shine their energy effectively through the air to be absorbed by solid surfaces like our bodies or furniture, that sort of thing. So a fan heater is a halogen heater is quite good if you're in a large room and you can shine that heater on you. So, for example, next to your desk or on your desk, because it's not trying to heat all of the air in the room. It's just trying to heat the person or the object it shines on. So you can get quite comfortable with being in front of the halogen heater in a large drafty room. So halogen heaters are useful in certain places, particularly where you've got large rooms, which are too large to circulate the heat with a fan heater. Convection heaters or some of these will sometimes be fan assisted, where they're blowing the hot air out. Effectively, yeah, they're fan heaters, they're convection heaters. They're trying to cycle the air in the room through the heating element. So again, they'll work well on the smaller rooms where you can keep the doors closed and just have that certain volume of air to run through the heaters. Does anyone have any questions on heating systems?
So in the chat, there are a couple of comments rather than questions. David says, many rural community spaces and houses use oil as they are not on the gas grid.
Mm-hmm.
I think much of what you say about gas boilers and systems also applies to oil, so worth pointing that out.
Yes, definitely.
And then also loss of system pressure, often due to tiny leaks. Make sure all pipework and radiator joints are tight and the bleed screws fully closed.
Yeah.
Monitor dial carefully while topping up so you don't overpressurize, as this can cause leaks and damage.
Absolutely. Yes, completely agree with both those comments. Thank you for whoever's generated those. Yes, obviously there's a lot of oil-fired systems which will be similar to gas. They'll tend to provide the heat to go around the radiators. Obviously, you know, gas is still effectively the cheapest way to be heating community buildings. If you're not on gas, then yes, you do have more limitations. Electric heaters may be a solution. One thing to be aware of, you'll often be recommended, if you are on a off the gas network, to look at air source or ground source heat pumps. They are good, but they do need to be installed in buildings which have got pretty good insulation. Because they're quite low heat technologies. Air source and ground source heat pumps produce sort of low temperature heat, but for long periods quite efficiently. And you've got to be able to store that heat in. So unfortunately, if you have a building which is very difficult to insulate, then an air source or ground source heat pump may not be the ideal solution unless you can insulate that building as well.
Can I just make a comment? Because sometimes I go into community rooms and in the loos you're met with a sign that says, warning, really, really hot water, extremely hot water. It, you know, I realised that actually that's because the setting is set too high, isn't it? Rather than the committee or whoever is in charge of the boiler just turning the temperature down. They've set it so high and nobody's doing anything about it other than putting little messages up by the taps warning people.
Yeah, and that's that's a very simple thing, because again, no one understands how the boiler works.
Yeah.
Okay, moving on. We'll have a look at some lighting and some appliances that you typically find in a community building. The lighting, I can pretty much guarantee with almost every building, doing something to improve your lighting system is probably the single most cost-effective thing you can do to save energy. It's often not that exciting, but the sort of more recent improvements in bulb technology with LED bulbs has reduced the energy consumption for lighting significantly. And if you're using older systems, I can guarantee you that moving to an LED system will save you a considerable amount of money. So we have tubes, obviously fluorescent tubes you'll be familiar with. T12, T8 and T5 are often the numbers you will see associated with them. They are, just to demystify that, those are 1/8 of an inch, and that's the thickness of the tube. So a T8 is 1 inch thick, T12 is 1.5 inches, and a T5 is 5/8. So you should be able to tell with a ruler what you've got there. T12s are the least energy efficient, T5s are the most. But certainly now, if you've got any 12s or 8s, they're probably worth replacing, and we'll have a look at that a little bit later on. compact fluorescent lamps, CFLs. These are the typical sort of low energy bulbs that people are sort of familiar with. The loops and spirals. Been with us for quite some time now, 30 odd years. Halogen, often smaller, these sort of cone-shaped bulbs with reflectors. Halogens, you'll know if you've got halogens because they get very, very hot when they're used, and they are shockingly inefficient at producing light because they generate so much heat as a byproduct that half your electricity cost is going on generating heat, not light. LEDs, available for a range of fittings now, available pretty much everywhere, probably the most common type of bulb you'll find. And if you've got some outside lamps, particularly on something like a sports club where you may have some flood lighting, you get some of these sort of more exotic types of lamps, like sort of sodium or mercury lamps. Just to be aware that you may have some sort of speciality lamps which may need a little bit more thought before replacing. Little bit of information about bulbs. The rating in watts is really how much energy a bulb uses. When we used to just have filament bulbs, obviously the wattage gave us a good idea of how bright they are. But it's important to remember that the watts is not giving you an indication of how bright they are. Watts is energy consumption. The higher the number, the more energy it requires. It's not going to tell you how much light it produces. This can be a little difficult for people who are used to the fact that obviously a 100-watt bulb was brighter than the 60-watt bulb. And people were very familiar with the idea of wattage meaning brightness. But it doesn't now. You really need to understand, to get the right bulb replacements for LEDs, that the wattage of an LED, about 3 or 4 watts, doesn't mean it's going to be really, really dull. It just means it uses very little energy. What you're looking for the light put is something that's measured in lumens. That will tell you how bright your bulb is, and also your color, which is measured in Kelvin. We'll look at those. I've got a couple of charts that explain those in a little bit more detail. And the color is important because this is where often people have bought a replacement bulb and then said, I don't like it. I don't like the light or the quality of the light that bulb is putting out. That's often to do with the color of the bulb replacement that's been chosen. And finally, of course, you've got the type of fitting. There's an image there which shows you some of the obviously the more familiar type of fittings, the screw cap and the bayonet, and the ones with 2 pins are probably most common that you'll find. So this chart just sort of gives you an idea of how the different bulbs have different energy requirements to produce roughly the same amount of light. So taking one in the middle here, the halogen at 42 watts, an LED is only 10 watts to produce the same amount of light, so a quarter of the energy use. Compact fluorescent a little bit more at 12 watts, and an old filament bulb at 60 watts. So that gives you an idea of the equivalent. That obviously 60 watts, 100 watts, you may have wanted these to be somewhere like a kitchen or an office that's quite bright. Something like the 25 watts and the 40 watts, these are the sort of things people maybe put in things like a desk lamp or something to be a bit more sort of cozy, something not quite as bright. But it gives you a rough idea of the savings that you can make. If you can bring this wattage number down and get the same amount of light, you're saving energy, because the wattage is giving you an idea of how much energy it uses. And yeah, the modern LEDs are by far and away the least energy hungry of any of them. The color, the Kelvin, this is important to note if you have for different areas of your building. People are used to the nice sort of orange glow of an incandescent light bulb. That's their 2700 Kelvin. You'll often see these described as sort of warm white or sort of bright whites towards the blue end. If you want your space to be sort of nice and cozy, look at something a little bit more towards the sort of yellow end. If you've got something like a kitchen or an office, or maybe somewhere like a gallery for art displays, you'll want the white to be sort of quite a white light, so it doesn't distort the colors. Whereas things like an orange light can make everything in that room look a little bit more orange. So it's good for cozy, not necessarily great for something like preparing food in the kitchen. So it's just to be aware of what color of light you want and how best to use it, because that often has come up with people not liking the light of a replacement bulb. Is often because it's a different color. For tube lights, the old sort of T8 and T12 fat tubes can be replaced with a T5, usually a direct replacement. With tubes, I would always recommend that you speak to an electrician with tubes. The problem with tube lights are sometimes the fittings can be a little brittle on them, and when you take out the tube, if you break the fitting, then of course you can't use the light. Because you've broken the fitting. If you want to replace the old tube lights with LED tubes, which are the best, the least energy hungry, your electrician may need to do a little bit of a rewiring job. So I'd always suggest that you get an electrician to look at tube replacements, because it can, with a broken fitting, if you get the tubes the wrong length, if you got the wrong sort of tubes, it can be a bit messy. So I'd recommend, particularly if you have a lot of tube lights and they're high mounted as well, you get somebody in to look at replacing those. And I'd always recommend you buy good quality. You can sometimes find some very cheap bulbs, LED tubes and bulbs on the market, particularly online. Watch out for the ones which seem very cheap, because they're probably imported and not EU standard. Replacing other bulbs should usually be straightforward. Most of us are familiar with these at home. Make sure you get the right fitting. Don't worry about, take the old bulb with you to the shop if you're not quite sure. And you can always ask and see if you can get the right sort of fitting as a replacement. And I'd always recommend buy one, particularly if you're swapping from, say, a compact fluorescent or halogen to an LED. Buy one and test that it's the right brightness and it's the right color. And then once you've bought one, of course, you can buy any others that you might need. So don't worry about maybe replacing all 10 in one go. Buy one, see if you like the light that comes out from it. One of the few things I can always recommend really is if you've got any halogen bulbs, replace them with LEDs. They will pay for themselves in a very short period of time. Because you can replace a 40 or 50 watt halogen with a 4 or 5 watt LED, and it's 1/10 of the energy consumption. With those bulbs only costing a few pounds each, you will very quickly save the money that you've spent on the new LED bulb on your electricity bills. For most of the compact fluorescents, if you use the room a lot, so things like entryways, sort of main hall, kitchen, if the lights are used a lot, they're probably still worth replacing with LEDs. You'll save the money back within a matter of a year or 2 years, depending on how much you actually use the lighting. In other rooms in place, sometimes like toilets, storerooms where the lights don't get used much, only replace those bulbs when the existing ones fail. If you don't use the light a lot, then you're not going to really see any saving by replacing the bulb. But if you've got halogens, or if you've got rooms that you use quite a lot, then I can practically guarantee that replacing them with LEDs will save you money in a fairly short space of time. A quick word on some appliances. Fridges, anything that produces heat or produces cold, generally uses a lot of energy. There's a nice image here of a sports club I visited with 3 fridges, because there were 3 sports clubs and each one of them wanted their own fridge. And when I went there, 2 of these fridges were empty because it was winter, and it was the cricket and bowls who don't use the sports facilities during winter. So for 6 months of the year, they had 2 fridges running, which were completely empty. Fridges, they don't necessarily cost a lot to use each year, maybe somewhere in the region of 40 or 50 pounds. But you'll often find they're sitting there plugged in, running, when they're often absolutely empty. They're not being used. So turning fridges off if they're not used is a very simple way of saving a bit of energy. And in this instance, it's quite common. These fridges were hand-me-downs. So you can see the image on the right here. It's got an ice box and the door is broken. So the thermostat in the ice box is in fact trying to turn the whole fridge into a freezer, because it's trying to freeze the whole thing. So not only was this empty, not only was this not going to be used for months, it was also trying to be a freezer. So that would have been just sitting there running, switching on silently every few hours during the day, during the night. And all it's doing is sucking electricity out of the hole in the wall. So watch out for fridges. They're silent users, because we don't worry about them. We get them out of the box and we plug them in, and they just get left on. But you'll often find that they're not needed. Fair enough, if you've got catering or events in, you need a fridge. But you'll often find that they're just for having coffee in the morning for an hour. You don't really need a fridge to keep milk going sour in an hour. So watch out for fridges and freezers. They can use a lot of energy. And if you haven't pulled them out in a long time, pulling them out and giving the back, the compressor, a dust or going over with a hoover is also worthwhile, because they'll accumulate dust, and that reduces their efficiency as well. Kitchens, one thing you ideally want to avoid in a kitchen is having your ovens and kettles and other sources of heat too close to your fridge and freezer, because then they fight each other. If you have a fridge next to the oven, when you put the oven on, you heat up the fridge, so the fridge has to go on to counteract the heat of the oven. So it's good if you can keep fridges, freezers away from very warm areas. It's good if you can keep them out of direct sunlight as well, though obviously that isn't always the case. And just have an idea really about other appliance use, particularly one of the culprits I see here on the right, the water urn. They're uninsulated. We all know how hot these get on the outside, because they're not storing any of the heat in. If you have those just heating water over and over again, it's a very inefficient way of keeping water hot, because it's not insulated. So watch out for leaving those on. If you need to heat a lot of water in a short space of time, they're fine. But watch out for them. There's the sort of silent appliance that can sit there plugged into the wall, just using your electricity. So does anybody have any questions on lighting or appliances?
There's just one comment in the chat, and David's put, if you have dimmers, they might not work properly with certain LED lights. You might need to change the bulbs and or the dimmer switches.
Yes, some LEDs are designed to work with dimmers. So again, that's just making sure you get the right one. The packaging for bulbs is a lot better than it used to. It'll often have some quite clear information now about the color, so the kelvin, whether it's sort of a warm white or cool white, and yeah, information about whether you can use it with a dimmer or not. But if in doubt, ask in the shop, and bring the old bulb with you, and explain what you need your new bulb to do. I've seen that often a lot of the people who have been upset with bulb replacement are simply because they've replaced the wrong replacement, if you like. They've gone from a sort of 60 watt warm white and gone down to a 20 watt equivalent cool white, and are saying it's too dark and it's not cozy. It's simply because the wrong bulb has been chosen, and it shouldn't be that difficult to get them right if you understand what to look for.
Okay, that's all the questions and comments in the chat anyway.
Fantastic. Just some final tips. If you don't take control of your energy use, you won't be in charge of your bills. It's having those meter readings, understanding the bills, understanding what your unit rate is, and of course being prepared to shop around. One of the simplest things you can do, because it doesn't cost you anything to do, there's no investment there other than a bit of time in checking out what your energy consumption is and whether you might be able to get a better deal. And the other thing is, understanding your boiler and your timer. I've seen this so often visiting community buildings where people are sort of scared of the boiler and no one wants to touch it. And if you can't control it, if you can't make it do what you want, then no wonder it's going to sort of eat your energy bills. Lighting, as I said, is probably one of the simplest ways to save money in a community building. Look at the bulbs. And what sort of use you want out of the building to make sure that you get the right type of replacement bulb. And checking for those drafts, all those small gaps, very easy for them to get ignored. Blown window seals, gaps around doors, very quick and easy to fix, and they make a surprising difference to keeping the heat in. And finally, don't be afraid if you need to get some specialist advice for things like your insulation or for your boiler system. Also, just say on replacement boilers, if your boiler is more than about 20 years old, it's worth considering replacing it because a new boiler will be considerably efficient than a boiler from 20 years ago. And certainly, I've seen in some community buildings boilers from the 70s still being used, and they will be about 60% efficient. A modern boiler is about 90% efficient. So they could save us a third on their energy bill by replacing the boiler. But that's where you really need to find somebody who knows what they're doing. Some links there, so people will be able to download a copy of the presentation later. So there's some information there, just a bit of advice on a lighting guide. The Development Trust Association for Wales, the Energy Action Group, so that's the broker service. There's a short video there on how to use storage heaters if you have them. Again, you see those misunderstood quite a lot. And there is some support available there. There's a project called Renew Wales, which may be able to provide you with some advice for energy efficiency at a community building. Sustainable Community Wales, that's a scheme that is currently going, still active, and that will provide, I think, bespoke sort of visit and guidance to a community building on your bills and your heating systems and whether it's suitable for solar, something like that. So if you do have a building that's difficult to heat or costing you a lot on the bills, have a look at Sustainable Communities Wales, see if they can help. Finally, if you do get any queries, there's advice available for households rather than community buildings. So those are for sort of domestic properties. If you get anybody contact you who wants to know potentially about saving money at home, there are subject to eligibility. There are a few schemes that are available to help people. And that's it. I think I've overrun slightly.
Well, we did start a bit late, but thank you, Gareth. That's been a very informative presentation, and hopefully everybody will find it extremely useful. I certainly have. And thank you once again to Gareth for joining us this morning and giving us a very interesting presentation on energy efficiency in buildings.
Thanks,
So,
Gareth. Yeah,
Thank you, Gareth.
Yeah, very helpful. Thank you.
You're welcome. And I said, I'm happy to hold on if people have got some particular queries. It's a bit odd doing it remotely, but if you've got specific queries about specific buildings, I'll see if I can point you in the right direction. Obviously, I could only cover some generic things on the presentation.
So if people do want to unmute, we can, have a general discussion, or if people have got questions they'd like to ask, then we just unmute yourselves rather than do it through the chat. David?
Yes, well, first of all, thank you very much, Gareth, Diana, Jackie, and the backup team. That was a very useful kind of summary, and something I think I shall share with my local community hall. Just a little strategic thought. I've just been looking at the draft Powys decarbonisation strategy, and there is a mention of community buildings in there somewhere. So it might be worth over the next few months or a year or so, keeping an eye on how that evolves to see whether there is any further sources of, excuse me, help or support that may become available to community groups as well as individuals as a result of that strategy.
Yes, I mean, I'd always hope that there is help available. As I said, at the moment, Sustainable Communities Wales has funding to provide support to community buildings on energy efficiency, and hopefully that scheme will sort of continue for the moment, really. So.
Yes, I've just had a little look at that. It's a programme of free support and advice available to communities across Wales to help improve the energy efficiency of the buildings they run. And that's looks like it's a partnership with 7Y Energy Agency and Welsh Government and Renew Wales, is it? Anyway, so that information is one of the links at the end of Gareth's presentation, so you can look at that in more detail and see if it's relevant to your organisations. Any other comments from anybody?
Yeah, just one point. It's very useful for our organisations, absolutely, but also, I guess, for people who are helping individuals, perhaps who may be in poverty, to actually pass some of that useful information on, in terms of saving money and better insulation and so on. Yeah. So yeah, that's helpful in many ways, I think. Gareth, thank you.
Yes, I think there were quick, easy things. Finding the drafts, or people often wouldn't think if the brush on the back of your letterbox falls off, people wouldn't necessarily rush to replace it. But I certainly know when mine did, my letterbox is flapping. I could feel the draft coming in. So those are quick and easy to do, and understanding the light bulbs. I think there has been a lot of misinformation about sort of people complaining about low energy light bulbs, and the packaging is a lot better now, but understanding which one is to use as the replacement, it should avoid most of that. And I think it's good if we do this in community buildings, then people get familiar with them at home, and then people can sort of learn and maybe having seen these things in community buildings will be more happy to have the same ones at home.
Anybody else want to comment on anything? If not, then we can draw the workshop to a close. And once again, thank Gareth very much for his time and expertise on this subject, which is
shame
very,
can't be there. It's all a bit odd talking to my computer in a room alone.
But yes, but thank you very much for joining us, everybody. It's been really nice to see you all, and I hope you found it helpful. And like I say, we'll be emailing you later with a feedback form and a link to the slides today.